All right. This is Math 6, Module 5, Lesson 8, Drawing Polygons in the Coordinate Plane. Excuse me. It says, determine the area of both polygons on the coordinate plane and explain why you chose the method you used. Then write an expression that can be used to determine the area of the figure. Explain how each part of the expression corresponds to the situation. Now, we need to find area. An area, in general, we would say for a rectangle is what? Length times width. That's for a rectangle. Area for a triangle is half the base times the height. And that's what it looks like we got right here, correct? Y'all see triangles and rectangles? Now, let's just look at example or the polygon. What's a polygon? It's an enclosed figure, correct? So if I was to draw a figure like this, is that a polygon? No, because it's not closed off. It has to be closed off, okay? Now, we don't know what kind of figure that is, but we can break this number one into two different shapes. Now we have a rectangle and a triangle. But what else do we need to find the area? What do we need to find the area? What? Okay, we need points, or we need some numbers, right? We need the length of the sides, right? So, can you tell me what the height of the triangle is? Not of the triangle. I got 4. So if we say 4 here, what's the base then? 2. Now, what is the width of the rectangle? 2. What's the length? I got 6. So now for number 1, we can say, let's do this. Number 1, we have this equation. Length times width of the rectangle. We have 6 times 2 plus what? Half 2 and the height of 4. Does everybody see where we get that? If we call the triangle A and the rectangle B, here's the area of A, here's the area of B. Add them together, we'll get the entire number 1 polygon area. So what is that? 12 plus 4? 16 units squared. Good. Everybody see that? Everybody understand that? Okay? Now, let's try and figure out number 2. How would you do number 2? You would what? Box it. Put a rectangle around it. Okay. We're going to put a rectangle around it. We're not going to box it. We don't want no violence in math. Keep it let's keep it civil here. So let's draw a rectangle around it. We got to enclose the entire thing, right? Now we have again a rectangle and a triangle. But are we going to add the area of the rectangle and the triangle here?
So you only do the triangle.
Then why did we draw the rectangle?
Because it's like diagonal, so you cannot like you cannot find outside that. I don't know how to explain.
All right. Let's find we're going to now take, let's call the box C, and let's call this D. Okay? So now what we're going to do is we're going to take, for number 2, it will equal the area of C minus what? Is it the area of C minus D? That's going to give you the area of the triangle? And if we take the area of C, the entire rectangle, and we add the area of D, that gives you the area of D? C. And that's going to give you the area of the triangle? Yes. You're trying to find D. So you're going to take, let's call this C1, C2, and this one C3. You're going to subtract the area of C1, C2, and C3. That will give you the area of D. So you could say D is equal to C minus our little triangles. Everybody understand that? So let's do that. C is what? Say it again. Yeah, it's a rectangle, so we got to find the area. What's the area? I got 7 and 6. 7 and 6, okay. So C is equal to 6 times 7, which is 42. Now, C1, C2, C3. What is the measurements for? These are all triangles, right? So we're going to half the base times the height. What is the base for C1? Look, you already got one right here. It's 7. That's the base of C1, right? So 7 times 3. Yep, there's 3. Well, if that one's 3, then C2 has to have one that is 3. And what is the other one? 1, 2, 3, 4, 5, 6. Okay. And C3 would be 1 and 6. Okay. So we have 7 and 3 is 21. Half of 21 is 10 and a half. Then we have 18 and half that is 9. We have 6 and half that is 3. So now go back to our original formula here. To find D, or our number 2, that is C, which is 42, minus the sum of C1, C2, and C3, right? We're going to add all those up. So what is that? 19 and a half, 22 and a half. 4.5? That's right. That's 12. Yeah, 12 and 10 and a half is. Yep. So now then, what is 42 minus 22 and a half? Is that 19 and a half units squared? Now, anybody got any questions on that? We took 42, we subtracted all of these, C1, C2, and C3. So either you could add all those up and subtract it, or you could just subtract each one. You could say 42 minus 10 and a half, minus 9, minus 3, and that will give you 19 and a half units. Everybody understand? There's a lot of different parts, a lot of moving parts here. All right.